And when you solve an absolute value, if you can remember back, it's been a long time, but back to September, we solved equations with absolute value. When you have an absolute value, you always have two parts or two solutions or two possibilities to be thinking about. So if you go back and think about what absolute value is, let me refer back to September here for a second. If we had something that said the absolute value equals 5, then that value of x could have been a positive 5, or the value of x could have been negative 5, because when I take the absolute value of a number, it comes out positive, whether it starts out negative or positive. So we had two different solutions for that. Now we made those a little more complicated back in September, as we will do with our inequalities, but there are two solutions. That's what's important to know. So when you are solving an inequality with absolute value, you have to remember the same thing, that you have two solutions, or kind of two things you have to look at, okay? So if our inequality and our absolute value is a greater than some number, okay? So if our absolute value is a greater than, and this would apply to greater than or equal to also, okay? Then my two cases is what I'm going to call them. The two cases that I'm going to set up are x is greater than b, or x is less than negative b. So you'll notice that in the second case, I am changing the direction of the inequality symbol, and I'm changing the sign of whatever that number is going to be. I also am inserting the word or between the two cases. So this is where it doesn't give you the word and or. You are going to have to know which word to insert there. And then remember, that plays a role in the solving of the inequality. Okay? If my absolute value is less than or equal to something, then my first case is x is less than that number, and case 2, x is greater than the opposite of that number. Okay? So let's look at the similarities of these things. The first case in both of these situations is exactly what the question started as without the absolute value bars. So the first one is just drop the absolute value bars and you'll solve it. Then you're going to place a word between the two cases. Here's my little trick. If you have an absolute value that is greater than or equal to, so here's my trick, you ready? If it's great or, so a greater, great or, but if it's less than, it works. I'm telling you, you're going to use it, so you can laugh and think I'm corny, but you're going to use it. I know you will, okay? So that's going to help you know what word to go there. So a greater than symbol, greater than or equal to, great or, less than. Again, the word itself is worth a point. So put it down there, okay? In case 2, in all of the absolute value ones here, I am switching the direction of the symbol. So it went from a greater to a less, here from a less to a greater. And then I'm changing the sign of the number to the opposite. Okay? You'll get that. It falls into place really quickly. Okay? So, two things. Two really, really important things to remember, as I have in red, capitalized, exclamation points. You must set up two cases. You cannot forget to do that. You'll remember that today when you're doing your OTL, because every problem is going to be like that. But when you get to the super goal, people forget it. They forget to set up two cases. So that's where my concern would be. But so you've got to think absolute value, two cases. Get those things in your head. The other really, really, really important thing is that the absolute value must be alone before you can set up your cases. And if you don't do that, I won't even grade half of it. Like the second half, all wrong before I even look at the first half. Okay? You have to get the absolute value isolated before this works. Okay? So, here we go. Number 1. Start off simpler. Absolute value of x plus 1 is less than or equal to 3. So the absolute value is set up already. It's by itself. We're ready to go. We're going to set up our two cases. Case 1 looks exactly like what you have there. Just drop the absolute value bars. Then you decide, is this and or? It's a less than symbol, so this is an and. In case 2, the left side stays the same, but we make 2 changes in the second case. 2 for 2. Greater than or equal to a negative 3. So in case 2, we switch the direction of the symbol and the sign of the number. 2 switches, 2 changes. Once you set this up, then it's exactly like last night's OTL. Once I get my cases set up, I do the same thing. I subtract 1. So I have x is less than or equal to 2. I subtract 1. And x is greater than or equal to negative 4. And I graph it. If you would like your helper graphs, that's fine. If you don't, that's fine too. Less than or equal to 2. Greater than or equal to negative 4. Because it's an and, I'm looking for where they overlap each other, and I get my dumbbell. And then remember that this answer should be written as a dumbbell answer, which for me says I have 2 numbers on the outside and x in the middle with 2 inequality symbols. So again, once you get the cases set up, then it's exactly like last night's OTL. Same rules and everything from that point on. Okay, the second one here. The absolute value is clearly not alone, so you have to get it that way. You have a couple of options. You could distribute the 3 first to get rid of my parentheses, or because the 3 is the coefficient of this whole term, I could divide by 3 first. My guess is that most people would think distribute, so I'm going to do it that way. So 3 times 4 is not 4. It's 12 absolute x. 3 times 3 is 9. Greater than or equal to 15. I'm going to solve for my x, so I'm going to add 9. So 12 absolute x is greater than or equal to 24. Divide by 12. Absolute x is greater than or equal to 2. So you solve for x just like you would solve for x if it was just x. And now I set up my cases. Now my absolute value is by itself. Case 1 looks exactly like what's there, just drop the bars off. X is greater than or equal to 2. This is a greater than symbol, great or. So or is my word. And then in case 2, I make 2 changes. I switch the direction of the symbol and the sign of the number. And I graph. Helper graphs are optional. I have x is greater than or equal to 2, or x is less than or equal to negative 2. It is an or, which means a union. So I am going to get my split graph here. And my algebra answer is just exactly what I have over there. I'm just going to rewrite it. So greater than or equal to 2, less than or equal to negative 2. Anytime you have a split graph, you have the word or in your algebra answer. Question on that one? My next one looks weird. I should have typed this in equation editor instead of just with my laptop because my absolute value bars aren't very distinct. So I'm going to make them a little more distinct. Those are the absolute value bars. Okay, so I have to isolate that absolute value before I can set up my cases. So my first thing is going to be to subtract this 12. So I have a negative absolute 2 minus x is less than negative 8. I'm going to now divide by negative 1. Ding, ding, ding. I'm dividing by a negative on an inequality, so I'm going to switch the direction of the symbol to greater than, and then negative 8 over negative 1 is positive 8. So this is important. I'm getting ready to set up my cases. In the midst of the solving, to get the absolute value, I have switched the direction of the symbol. This is where you determine your word. This is where you determine if it's an and or an or, not at the beginning of the question. Okay, so once the absolute value is isolated and you set up your cases, that's where you'll look to see what word's going to be there. Okay, so I'm going to have 2 minus x is greater than 8. The first case always just looks like exactly what you have, drop the bars. It is a great or than, so I'm going to have the word or, and then case 2, left side stays the same. 2 changes, the direction of the inequality symbol and the sign of the number. Okay? So again, I'm going to emphasize that this is where I determine, when I get ready to set up my cases, that's where I determine what word I'm putting there, not the beginning of the question. Okay, so we solve. Subtract our 2, so x is greater than 6. Divide by negative 1, ding, ding, ding. Switch the direction of that symbol. X is less than negative 6. And then on the other one, subtract 2. It's always the same math on both. Negative x is less than negative 10. Divide by negative 1, ding, ding, ding. X is greater than 10. Simple number line, only the numbers you need. So less than negative 6, greater than positive 10. Because it is an or, we are looking for the union. That means we're going to union them, combine them, put them all together, which means I end up with exactly the same final graph as my helper graphs, a split graph. Oops. Okay, question on that one?